Hey there, Longhorns. It's Miss Campbell, and today we're going to be going over finding the surface area of composite figures. All right, so composite figures, remember, they are shapes that are made up of smaller shapes. So if you look at our picture right here, we have a cone on top of a cylinder. Okay, so there's not like one single shape that would describe a cone on top of a cylinder. So we have to think of it as the two separate ones. And so surface area, y'all remember, surface area is the area of the outside of the figure. So we have our method that we're going to use. Okay, first step would be to find the surface area of figure 1. So I'm going to call figure 1 the cone. All right, so I would find the total surface area of my cone. Step 2 would be to find the surface area, the total surface area of that cylinder. Okay, and then here you see this step 3, find the area of the shared surface. So between the cone and the cylinder, there's this circle, right? Okay, so that circle is the one that's shared. And so we have to be careful. We don't want to count that too many times because it will affect our final answer. And we actually don't want to count it at all because is this circle on the outside of the figure? No, it's on the inside. It's not there at all. So what we're going to do to account for that is we're going to subtract that out 2 times. Because think about it, when we do the surface area of the cone, we're including that circle. So that's 1 time. Then when we do the surface area of the cylinder, we're also including that circle again. So that's 2 times. So whenever we have, like whenever you add the surface area of the first one and the surface area of the second one, you're double counting that circle. And we don't want to count it at all. So what we do is we add the total surface areas and then we subtract out 2 times that shared area. So that's how we're going to take care of it. So that is our method for any time we have a surface that is shared, that's on the inside, it's not going to be on the outside. So surface area of one, surface area of the other one, take away 2 times that shared area. So we're going to start with our first example. Here's a pyramid on top of a rectangular prism. So first thing we need to note here for the pyramid, the sides are going to be the same as the prism. So they're 20 by 20. Okay, so this side here is also 20. And then the slant height of our pyramid is 16, so that's our L, slant height. So let's go ahead and calculate the surface area for that pyramid. So for the pyramid, it's 1/2 P times L plus big B. So perimeter, we have 4 sides and they're all 20, so 20 plus 20 plus 20 plus 20, okay? So that's going to be 80. So our perimeter is going to be 80. And the other thing we need to know, our slant height is 16. And then big B, the area of that base, well, it's a square, a rectangle. You would do base times height. So 20 times 20 in this case. So this can be 400. All right, now we'll just plug in. So the surface area of our pyramid is going to be 1/2 times our perimeter, which is 80, times our slant height of 16, plus 400. And let's go ahead and type that in. So we will do 80 times 16, and then we only want 1/2 of that, so I'm dividing by 2, plus 400. So it's 1,040. So the pyramid is 1,040 inches squared for our surface area. Now we need to do the prism. Okay, the surface area for a prism is perimeter of the base times the height of the prism plus 2 times the area of the base. So you have to calculate the perimeter. Again, our base, okay, remember for the rectangular prisms, we're using the bottom side there as our base. Okay, so the 2 sides of it are 20 and 20, but there's 4 sides. And you'll notice it's going to be the same perimeter as your pyramid because they have that same base. So it's 80. Okay, area of the base, big B, base times height, 20 by 20 again. So if you can recognize that these things are repeated, you don't have to calculate them again. All right, and now the height of our prism. Remember, this is the height of our prism, and it's going to be 17. That's the distance between the two bases. So 17. And now we will just plug in. So we have 80 times 17 plus 2 times 400. And I'm going to get this in my calculator. 80 times 17, that's 1360, plus 800, because 400 times 2. All right, plus 800. So for our prism, it's 2,160. Okay, that's total. So pyramid is 1,040 and prism is 2,160. Now remember, we have to find that shared area. So the shared area here is going to be big B, okay, that base. So the shared, okay, it's this square here, this 20 by 20 square. So 20 times 20, which is 400. And so now for our total surface area, the composite, you're going to do shape 1, which is 1,040, plus our shape 2, which is 2,160, minus, and we're going to do in parentheses, 2 times the area of that shared part, so in this case 400. So your composite area, all right, so 1,040 minus that is going to be 2,400 inches squared. All right, so there we go. I'll do another example. Here we have our cone on top of our cylinder. So for a cone, the surface area for a cone is pi r L plus pi r squared, because remember the area of a circle is pi r squared. All right, and then now we have, we just need our radius and our slant height here. Key thing, the 6 is the diameter. So the diameter is 6. So that means our radius to be 6 divided by 2, so our radius is 3. Okay, the slant height of our cone, L, is 7. So now we'll just plug in pi times 3 times 7 plus pi times 3 squared. And we're going to type this in. Now, if you are using an iPhone calculator, it's going to be a little bit difficult. So I would really recommend using the Desmos Scientific one or that TI calculator that we've sent you information on before. So pi times, and I'm going to use parentheses in here. If you use parentheses, I'm on an Android one. So if you use parentheses, this will be easier. So pi times 3 times 7, close parentheses, plus new parentheses, pi times 3 squared, close parentheses, and then we press enter. And we're going to round this to the nearest tenth. So our cone is going to be 94.2. Now the cylinder. Okay, it's 2 pi r h plus 2 times pi r squared. Again, our radius of our cylinder is going to be the same as the cone because they share that circle, so r is 3. But now the height of our cylinder, the distance between the two circles, h, is 9. So now we will plug in 2 times pi times 3 times 9 plus 2 times pi times 3 squared. Alrighty, getting my parentheses here, 2 times pi times 3 times 9, close parentheses, plus 2 times pi times 3 squared. Okay, press enter. So our cylinder is 226.2 because it's 0.19, so it's going to round up to 0.2. All right, so we have our cone and we have our cylinder. Now we need the shared area. Okay, so the shared area. That jumped down a lot. Okay, we have to think. My shared area is this circle. So we have to find the area of that circle. So we're looking for pi r squared. So pi, and then our radius is 3, so 3 squared. And you'll notice a lot of times you're going to be subtracting out the base. Okay, so for the circle, for the cylinder, it's that circle. And then, if you have a prism and a pyramid, it's big B. So we have 9 times pi, because 3 squared is 9. All right, so we get 28.3. So now the composite area, we're going to take our cone and our cylinder and add that together. So 94.2 plus 226.2, and then we're going to subtract out 2 times that 28.3, because remember the circle's counted twice, so we don't want that. So let me go ahead and do this. 94.2 plus 226.2 minus 2 times this 28.3. Okay, and we will get 263.8 units squared, because they don't give us the unit. So there you go. All right. Next example. Okay, this one, we've got a triangular prism on top and then a rectangular prism on the bottom. So it's 2 prisms. So for the triangular one, okay, we have to remember on a triangular prism, your triangle is your base. So you have to find the perimeter of this triangle. So P is going to be here 8 plus 12 plus 12. Okay, so 8 plus 24 is 32. And then now we're going to calculate the area of that base. Since it is a triangle, we have to do base times height divided by 2. So the base of our triangle is 8. The height of our triangle is 10. Divided by 2, so it's going to be 40. And then now we need the height of our triangular prism, and that's the distance between your 2 bases. So y'all look, this is running parallel to this side of our rectangular prism, so it's 8. So the height of your triangular prism is 8. So now the surface area for the triangular one, remember it's a prism, so it's perimeter times height plus 2 times the area of the base. So we have 32 times our height of 8 plus 2 times our area of 40. So 32 times 8 plus, and then 40 times 2 is 80, so plus 80. So 336. And that's your triangular prism. Now we need to figure out the surface area of the rectangular prism. So now, again, perimeter of the base times the height plus 2 times the area of the base. So for the rectangular prisms, we're using the bottom as our base. So we see we have a side of 8 and 18. So perimeter is 8 plus 8 plus 18 plus 18. Okay, and y'all, if you understand that you take one side, multiply by 2, the other side, multiply by 2, and then add them together, do that. But if you like to add all the sides independently, that is just as good. So 36 plus 16, so this is 52. Okay, the area of the base. Okay, the area of our base, it's 8 by 18, is base times height. So 8 by 18. So 18 times 8 is going to be 144. So that's the area of our base, and then the height of our prism is 10. So now for the rectangular prism, okay, the surface area is perimeter times the height plus 2 times the area of the base. So our perimeter is 52 Our height is 10, and then 2 times 144. So for our rectangular prism, okay, 52 times 10 plus, and it's going to be 808. All right, so our rectangular prism is 808. Now the shared area, this one's going to be a little bit different. You have to think here. Okay, only this base of the triangular prism is sandwiched between, right? But again, we've counted it once with the triangular prism, and then we've also counted it when we've done our rectangular prism. So we have to find that area and multiply it by 2. So this base here, well, not the base, but this face of the triangular prism that's being shared, it's 8 by 8. Okay, so the shared area, it's 8 by 8, so 8 times 8, so it's going to be 64. So now our composite area will be 336 plus 808 minus 2 times 64. So 336 plus 808 minus, and then 64 times 2 is 128. So it's 1,016. All right, so there we go. Okay, so if you are in pre-AP, stay with me for this. If you're an academic, you can stay and watch because I'm going to explain this a little bit differently. And so maybe there's another way that you might want to see the problem. So just hang with me if you want to see another way to do it. But if you're in pre-AP, let's stay because we need to kind of talk about a couple different things. So for here, we can see a rectangular prism on the bottom, and then we have a half cylinder on the top. Okay, so this one's a little bit different. So we kind of have to think, okay, what am I going to have to get rid of on this cylinder, right? So for the cylinder, what we're going to think about is we're going to just do half of the surface area of this cylinder. So we're going to do half of the surface area of a cylinder because basically we're taking a cylinder and we're cutting it directly in the middle, you know? So we only want like the front half of it. So if we do half the surface area, that's all we need. Then we have to think about, okay, what piece of this rectangular prism is going to get counted in here? Because if we're doing the cylinder, think about the cylinder doesn't have any of the interior surface here accounted for. We're only going to be counting that shared part once with this rectangular prism. So we're not going to follow our usual taking out the shared area twice, because in this case, it's only counted once because of how the cylinder is positioned here. Okay, so we're going to do half the surface area of the cylinder plus the surface area of the prism. And then we're going to take out one of the bases of the prism. Okay, so you can kind of think of it like, oh, with the surface area of the prism, instead of adding in 2 of the bases, I'm only going to do 1. So what this is going to end up looking like, it's going to be, remember for a prism, it's perimeter times the height. But here, instead of 2b, it's just going to be 1. Okay, one base, because we only need the 1 base on the bottom. So let's go on ahead and get to it. Cylinder. Okay, cylinder is 2 pi r h plus 2 times pi r squared. So for our cylinder, the radius is 3, okay, r is 3, and then the height of your cylinder is the length of this, so it's 10. So we're going to go here, 2 times pi times our radius of 3 times our height of 10, plus 2 times pi and then radius squared, so 3 squared. We're going to type that in. But again, we only need half. So I'm going to use parentheses, 2 pi times 3 times 10 plus 2 times pi times 3 squared. Oh, I totally wrote 3 cubed here, didn't I? 3 squared. All right, 3 squared. Okay, press enter, and that's 245.04, so it's just 245, right? But again, we only want half of this, so we need 245 divided by 2. So 245 divided by 2 is going to give us 122 and a half. So this is for our cylinder part. Now we're going to do the rectangular prism part. And again, like we said, we're going to do the total surface area, but we're not going to account for both the top and the bottom base. We're only going to account for one of them because one of them is sandwiched in between here. So the prism, okay, it's perimeter of the height, or perimeter of the base times the height plus, and like we said, we're only going to do one base. Now, if you want to do the total surface area and subtract out one base, like I have it written here originally, that's fine. You can do that. But I want you to kind of think, okay, what do I not need to include from the start? So now we're going to have to look here. Our base that we're using for the rectangular prism is the one that it's sitting on. Okay, so 10 inches and 6 inches are our sides. So the perimeter would be 10 and 10 and 6 and 6. So we have 20 plus 12 plus 32. And then the area of that base is 6 by 10, so 6 times 10, so 60. And then the height of our prism is the actual vertical height, so 6. So now we'll just plug in. So perimeter was 32, the height was 6, and we're only doing one base, so 60. So 32 times 6 plus 60 is going to be 252. So our prism is 252. So now the total area, I'm just going to call it composite, will be our half cylinder, so 122 and a half, plus this 252. So it's 374.5. All right, so there we go. And now here's our last example that we're going to do. And again, we've done this example before, but I'm going to show you how to do it with a lot less work, a lot less double counting. So we need to think, all right, from this cone, do I need the entire surface area of this cone? No, I only need the lateral part, the top part. Like if it was an actual ice cream cone, I just need that piece. So for my cone, I only need the lateral. So it's pi r times the slant height, okay, pi RL. Now, for my cylinder, okay, think about that. For my cylinder, I need the lateral surface area, and then I only need one base, because remember the other base up here is actually on the inside of the figure, so we don't want to count it. So for my cylinder, I'm just going to need 2 pi RH, that's my lateral, plus one base. So pi r squared. We don't need the 2 pi r squared because we don't need both bases. So let's go on ahead here. Let's see. My radius, well, we can see the diameter is 6, right? So my radius is going to be 3. My slant height from my cone is 7. And then my height of my cylinder is 9. So those are the 3 values I need. So I'm just going to plug in. Cone. We're going to do pi times 3 times 7. So 21 pi is It's 65.97, so that's going to round to 66. Okay, because we're rounding to the nearest tenth, but you see that 7 is going to make the 9 go up, which makes the whole number go up. And then my cylinder, I'm going to do 2 pi times, or my radius is 3, and then my height is 9, plus pi times 3 squared. And so we will type this in. Okay, 2 pi times 3 times 9 plus pi times 9, because that's 3 squared. Okay, we can press enter and we get 197.92. So 197.9. And now for the composite area, we do 66 plus 197.9. 197.9 plus 66 is 263.9. All right, so yes, if if you just want to think of these things as what parts do I need and not count, not double count things that you don't need right from the beginning, do that. If that doesn't make sense for you, just remember, I need the surface area of one shape, surface area of the other, but then that shared area, sometimes it has to come out twice, like in this example, but then other times you got to kind of reimagine and think it only has to come out once, like on this example with our little lunch kit. So that's all there is to it for surface area of composite figures, and I'll see you guys in the next one. Have a great day.